Hello, my name is Andrew Arma, and this is my Physics 2212 Lab 1. In the first lab of this course, we investigated the property of charge using strips of tape. The experiment was performed by imbuing the tape of a charge by stripping the electrons from one piece by ripping it off of another. This resulted in the tape interacting with other charged objects. The main principle this lab report is illustrating is the properties of charge and their interactions with electric fields. Electric fields propagate outwards from a positive charge and inwards towards a negative charge. Positive charges move with an electric field and negative charges move against it. The result of this is that charges of the same polarity repel each other, while charges of the opposite polarity attract. The primary way in which an object gains or loses charge is by gaining or losing electrons. In a neutral atom or substance, there are equal amounts of protons and electrons. Due to the principle of superposition, the fields cancel out, and the net electric field at any point around the atom is zero. The first step of this lab is to tear the test tape off of the base tape. This creates a charge in the test tape. The polarity of the charge is determined by how the tape reacts to an object whose charge is known. Since the test tape was attracted to a negatively charged pen that I ran through my hair, and a normal piece of tape that hadn't undergone the process wasn't, the tape must have a positive charge. If you repeat the process of creating the test tape, you get another piece of tape with roughly the same amount of charge that repels the test tape. Through this repulsion, we can calculate the magnitude of the electric force acting between the tapes. When one piece of tape is held beneath the other at a distance of about 1 centimeter, the tapes repel each other, causing one of them to float slightly. Since the tape isn't accelerating, we can assume that the force of electric repulsion and the force of gravitational attraction are equal. From this, we can set the equations for electric force and gravitational force equal to determine the charge of the tape in coulombs. We can also treat the charges as centered at a point in the middle of the tape for simplification. The tape weighs about 1 gram per meter and is about 0.2 meters long, so the gravitational force on a piece of tape is about 2 newtons. Since the fundamental unit of charge is the electron, dividing the charge of the tape by the charge of an electron reveals the amount of missing electrons to be 9.23 times 10 to the 11. This is roughly 900k atoms for every missing electron in the tape. The experiment proceeded as expected for the most part. However, I wasn't able to get the test tape to float above the other tape consistently, so I had to estimate the separation distance. Part of the reason for this error is the ability of electrons to float from one place to another. Electrons like to have a uniform density, so if an object with too many electrons touches an object with too few electrons, the electrons will flow into the positively charged objects until the two objects are in equilibrium. When my hand touched the positively charged tape, electrons from my body flowed into the tape, decreasing the magnitude of the tape's charge and lessening the visibility of any electrical interactions it would have. Hypothetically, if protons and electrons swap charges, nothing that was observed today would change. This is because the sign of the charge only matters relative to other charges. If protons were negative and electrons are positive, protons would still repel each other and attract electrons. In conclusion, ripping the test tape off of the base tape took electrons away from the test tape and gave it a positive charge. This gave it the property of repelling positively charged objects like other pieces of tape that had undergone the same process, and attracting negatively charged objects. And over here is my code to simulate the test tape floating above the held piece of tape. The orange arrow represents the electric repulsion, while the red arrow represents gravitational attraction. Notice how they're both equal in magnitude.